This video covers topic 13.3, factoring when a is greater than 1. So the bell work asks us if the table to the right is an example of direct variation. If so, write the equation below. So they give us a table where x's are 1, 2, 3, y's are 4, 5, 6. Anytime we have a table, we want to go straight to the calculator. In order to figure this out, we're going to use stat, edit, and put the table in exactly like we see it. So in L1 are our x's, 1, 2, and 3. In L2 are our y's, 4, 5, and 6. From here, we click Stat, scroll over to Calc, choose option 4, which is LinReg. Click Enter as many times as it takes. So our equation would be 1x plus 3. Now the question asks if this was an example of direct variation. Direct variation means that there is not a value after the x. So something like 5x or 2x or 35,000x, but nothing that follows is an example of direct variation. So no, this is not an example. So we don't write the equation below, which is why I wrote it up here. You could also write it above the table. But the big thing here is that direct variation means there's no number after the x. So today we're asked to factor when a is greater than 1. So when we have things like this, 3x squared plus 5x plus 2, keep in mind that sometimes they do like to change up the order on us, so make sure that they're always x squared, x, and a number. If you're looking at something like this, the first thing we check is for a GCF. There's no numbers that 3, 5, and 2 all share. So I will go straight to the box. So 3x squared and plus 2. My first numbers and my last numbers are the two pieces that automatically go into my box. Remember that you multiply these for your product. So 3x squared times 2 is 6x squared. Your sum is always your x value that's listed nowhere in your box, but is listed in the problem. So we are looking for two numbers that we can fill into the missing holes that multiply to 6 and add to 5. I use my calculator and take the product number, 6, and divide it by x. Note that 6 is nowhere in my box, but it came from the two pieces in my box that automatically go in, the 3 and the 2. So from here, I've put the product in my equals. I've gone second graph to look at the table, and I am searching for the sum. So I am not looking for the number 5, but I'm looking for two numbers that I could put in those missing pieces that would add to 5. 1 plus 6 is 7, that's not 5. 2 plus 3 is 5. So I will put in a 2 and a 3. Remember that these have x's because the only way to add to 5x is if you have 2x and 3x. From here, I take out my GCFs, what they all share in the columns and the rows, and only the columns and the rows. You do not go horizontally and diagonally or up and down only. You go up and down, side to side, side to side. So up and down, 3x squared and 3x share the number 3 as well as an x. 2x and 2 do not share x's, but they share a 2. 3x and 2x do not share any numbers, but they do share a letter. 3x and 2 do not share any letters or numbers, so we put a plus 1 because everything shares a 1, but we look for greater than 1. So my factors are 3x plus 2 and x plus 1 as my answer. Now, if you switch the 3 and the 2, your side and top will be the opposite of mine, but you should still get the same side and top, not as what I have listed, but like if my side is x plus 1 and you flipped them, yours should be 3x plus 2. So you should still get the same factors, just not on the same side. So problem 2, we have 5b squared minus 17b plus 6. There are no GCFs, there's no common factors here because 5, 17, and 6 do not share anything. So I will go straight to the box, 5b squared and plus 6. I multiply these for a product of 30b squared. My sum is that middle number that is listed nowhere in my box. Remember, the word product means multiply, so my product is happening through multiplication. You just look or search for the sum in your problem. So in y equals, I'm going to put 30 divided by x and look at the table. I'm looking for two numbers that will add to a negative, so I'm going to look up in the negatives because none of these in the positives, they're positives and positives, and you can't add two positives and get a negative. Remember, I am searching for two numbers that will add to negative 17, and negative 2 and negative 15 would add to negative 17. So negative 2 and negative 15. Now again, the order in which you write these does not matter. If you switch them up, then your top will be my side, and so forth. They will just switch. So 5b squared and negative 15b share a 5 and a b. Negative 2b and 6 share a 2, and it is negative because the top number, or the closest number, the factor, is negative. 5b squared and 2b do not share any numbers, but they share a b, so you can put 1b or just a b. And then negative 15b and 6 share a 3, and because the 15 is negative, my number will be negative. So your negatives basically follow what the numbers you got from the calculator are. Okay. So my factors are 5b minus 2 and 1b minus 3. And again, if you just put b minus 3, that is okay. A quick way to check is to make sure that the first number and the first over here, so 5b and 1b, make sure those do equal 5b squared. And negative 2 and negative 3, make sure those do multiply to this last number over here. If they don't, either you picked the wrong factors or you took out the wrong GCS. Problem 3, we have 6y squared minus 5y minus 4. For that, there are no GCFs because there's nothing you can put into 6 and 5 and 4. You can take a 2 out of 6 and 4, but not out of 5, so we can't take it out. So I have 6y squared and a minus 4 that automatically go in my box. I multiply them for my full product of negative 24y squared. My sum is negative 5y. So I put negative 24 into y equals, and I look at the table. Remember, I am looking for a sum of negative 5. I only look at whole numbers, and I can scroll past anything that would not give me a 5 or a negative, and 3 minus 8 would give me a negative 5. Now note, I said 3 and minus 8, so 3 and minus 8. The signs that I say to get negative 5 are the signs I write. So if you say 3 minus 8 would give me 5, you better have a 3 and a minus 8 or a negative 8. From here, I take out my GCF. So 6y squared and negative 8y are both even, so they share a 2 and they share a y. 3y and negative 4 are different numbers and they don't share a y either, so we put a plus 1. 6y squared and 3y share a 3 as well as a y. Negative 8 and negative 4 share a negative 4. Remember, they do not share a negative 8 because if you only have 4, you can't take 8 out of 4. Quick check, 2y times 3y is 6y squared. 1 times negative 4 is negative 4. So my factors are 2y, come on, plus 1, and 3y minus 4. When we look at problem 4, we have 12c squared plus 11c minus 5. There are no numbers that 12, 11, and 5 share, so I go straight to the box. I have 12c squared and a minus 5. I multiply these for my product. My full product is negative 60c squared. My sum is 11c. So I'm looking for two numbers that would multiply to negative 60 and add to 11. So I put the product into y equals, go to my table, and search for my sum of 11. 1 minus 60 is negative 59, negative 28, negative 18, negative 11, but we need a positive, so I keep going. Well, what if I did the opposite signs? 15 minus 4 would give me 11. So I have a 15 and a minus 4. So 12c squared and negative 4c share a 4 and a c. 15c share a 5. Remember that when I say share, I am specifically referencing a number that you could divide out evenly from both numbers that you're looking at. 12c squared and 15c share a 3 as well as a c. Negative 4 and negative 5 share a negative 1. Quick check. 4c times 3c is 12c squared. 5 times negative 1 is negative 5. So my factors are 4c plus 5 and 3c minus 1. Problem 5, 4, 19, and 5 do not share any numbers, so there's no GCF. I write my first and last, multiply them for my product. My sum is the one not listed in the box, but listed in my problem. So I put negative 20 in y equals, and I look in the table for two numbers that could get me to negative 19. 1 minus 20 would give me negative 19. So from the calculator, I have a 1 and a minus 20. I take out my GCF, so 4x squared and negative 20x share a 4 as well as an x. 1x and 5 do not share anything, so they share a 1 as a placeholder. 4x squared and x share an x. Negative 20x and negative 5 share a negative 5. So we have 4x plus 1 and x minus 5. In the quick check, 4x times x is 4x squared. 1 times negative 5 is negative 5. Last problem, problem 6. These do not have any GCFs. There's nothing that they share. So we have 6k squared and plus 2. Multiply them for my product of 12k squared. My sum is 7k, so I'm looking for two numbers that will multiply to 12 and add to 7. 3 plus 4 would get me 7. From here, 6k squared and 4k share a 2 as well as a k. 3k plus 2 share a 1. 6k squared plus 3k is a 3k. 4k plus 4k and 2 share a 2. 2k times 3k is 6k squared. 1 times 2 is 2. So my factors are 2k plus 1 and 3k plus 2.